All right. Apparently, I am live. I hope everyone can hear me. Okay, sweet. We're live. Welcome, everyone. My name is Jordan, and I'm super excited to be here today. This is the 8th episode of the SolidWorks Live Design Series. And I've been watching every episode. That's the first reason I know that this is episode 8. The second reason is 8 is my favorite number, so I wouldn't have forgotten that. That's a little bit about me. Some more about me is I am coming to you live from my garage today. I get into a lot of construction projects. Actually, I don't need these headphones. A lot of construction projects, and I'm getting into woodworking as well. In fact, if I show you around here, we're going to be creating a set of stairs today, so we'll save that for later. But you can see I'm in Cleveland, Ohio. It's kind of cold over here. It's the high 30s still. I've got a wood-burning stove, and you can see how well I've cleaned up. Here's my little studio, and I just shoved everything in my garage to the other side of it. But here's the clean part, the background. Nice, organized, ready to go for this little session. I'm excited because we're going to be creating something that I need to create in real life. I've got someone asking for a set of stairs to be built, and we're going to work together to make that model. Now, you might be thinking, like, stairs, really? That's so simple. You just draw a little zigzag and then extrude and you're done. But that is not the case whatsoever in this scenario. We want to be expert modelers. We want to take it up to the next level. And what I mean by that is we want to be master modelers. We want to be the master of the model, in fact. When you give that model a change or switch a dimension, it better do exactly what you expect it to. So what we're going to do is not just build a set of stairs, but a set of stairs that is going to react to any change, any height, width, or any parameter that we want to switch up so that it can be applied to any application. You can think of a well-behaved model as like a well-behaved pet. You know, that's why that's why I say, you need to master your model. You need to master your modeling skills to really take it up to the next level. So that's what we're going to be doing. There's a lot involved here. We're going to be covering equations, linked values, and some really cool tips that I don't even know if my SolidWorks colleagues on the phone or on this stream, even know. So I'm going to show you a few little hacks in the software to make it do some really cool things, and I think you'll appreciate it. Now, one of the things I've been most impressed with over all of these streams is how diverse our international audience is. So we will be paying attention to the chat. I want you guys to all give a shout out if you haven't already. I see that some have. Tell me where you're from, because I think the fact that we have such a diverse international audience is the coolest thing ever. But also tell me what your favorite modeling mode of SolidWorks is. So do you like sheet metal, weldments, surfacing? There's so many different modes, just general part modeling. Let me know. If you appreciate this session, there's no telling how long we're going to do this. We got a lot of sessions planned out in the future. I love this format. My two favorite things are modeling and talking, so I feel like I was built for this. And if you like it, I'm sure if you hit the subscribe button and hit the like button on this post, SolidWorks will invite me back to do another episode. And advanced surfacing is one of my favorite topics, so if you like that, give that a shout out and we can make that happen possibly. All right. So let's get started. The challenge at hand, one of the issues with building stairs is the fact that you can buy components or lumber from the big box store, right? But this right here is called the stringer. So we're going to have to talk about some of the terminology really quick. This entire piece is called the stringer. And then to get on the same page, these vertical portions of a stringer are called the rise And the horizontal portion of the stringer, that's called the run. So when I say rise and run, now you know what I'm talking about. We are going to have an overall height here, but that height is going to be dependent on however tall our deck or our porch is, right? So the problem with these pre-cut ones is if the leftover step all the way at the top, stepping onto the deck or the porch or whatever it may be, is taller or shorter than each one of these, the rise of each step, then that's a tripping hazard. Because you, as you're going up the stairs, you get kind of into the groove, and then if one is a little bit off, you can trip. So people hack around this by trimming a little bit off the top of the top stair to kind of even it out. But that's a hack. We are going to be master modelers by the end of this episode. And since we all have SolidWorks, might as well let it calculate the perfect size step for the stringer from the get-go. All right? The other big benefit here is, check this out. The price, $42.55 at my big box store. That's pretty expensive. And if we take a look at the specs on this, you'll notice that it's 11.25 inches by 1.5 inches. So that's a standard 2x12, and it's 96 inches long. So that's a 2x12 by 8 feet long. If we take a look at what that costs, just buying that, $16.57. That's like a third of the cost, and then we can also have the perfect size step in this staircase. All right, so let me check out these comments. Weldments, some are saying. Others are saying, oh, you're in the right place for weldments. Now, Mike Sandy, my friend Mike Sandy, did an in-depth overview of weldments when he designed his desk. That was a couple episodes ago. And definitely go back and check that one out if you haven't already. We're going to kind of pick up from where he left off. So that's great. So Kali and Ray Fox. What's up, Ray? And Eric Beatty's in the house today. That's great. Muhammad. All right. Excellent. Raise your volume, bro. All right, I'll bring the mic a little bit closer. Usually people are complaining that I'm way too loud. All right, so let's go through this. First off, let's take a look at what we'll actually be building today. These stairs right here. This is what the model's approximately going to look like. I don't think we'll get to the railings, but this model is available for download. We'll post this link. You can see the URL in my web browser, but you could post this. We'll post this link in the description of this video below so that you can download it. And it comes packed with comments, so you could fire up the part reviewer to go ahead and click through feature by feature with my notes on it. There's also the lumber library that I'll be using. Mike Sandy used this on his presentation earlier. So that is just a library of profiles, custom lumber profiles, or standard lumber profiles, I should say, that you can reference. And just to show you some of the power of our weldments capabilities, the garage that we're in today, I actually designed. Now, it doesn't look like that. I didn't get approval by my wife for the second floor with the stairs. I just have storage up there right now. It's shorter. It's okay. It's really cool. But not as cool as this one. This was my dream garage. Maybe someday. And all these are available for download on mysolidworks.com. Again, we'll post a link for those. So without further ado, let's jump into SolidWorks and get busy. Now, I gotta apologize, the international audience, I know everyone uses metric. For whatever reason, we use inches, and that's the size of the lumber that we're using, so I'm gonna have to use inches in this case. Most other sessions so far have been kind enough to poll the audience, metric or inches, and have gone with that. I'm gonna have to just make the executive decision and start with inches here. All right, now, while we're starting, I'm going to just go ahead and start with a sketch, a reference sketch. So, or you could call this a layout sketch. In fact, I think Brian Zayas, my friend Brian Zayas, started off with a layout sketch. And who here has used the midpoint sketch line tool? This was introduced a few years ago. You could start at the midpoint and drag it outwards. That's pretty cool. I can't say that I use it all the time, but on a live stream, definitely. And then we can add dimensions to fully define this. Maybe I'll throw this in at 80 or so. But what we want to do is we want to control this by a set of variables. And if you think about like a good computer program, if you've ever written a program at all in the past, what do? You start off with your variables and your inputs. So that's what we're going to do. We know that there's going to be a height. I'll just abbreviate that with an H. And by the way, what I've done is I've jumped in. Let me type in the height. We'll say 36 inches for now. Maybe I moved too fast right here. I'm going to show you a few tips. The equation dialog box, that's right here at the top of my toolbar. That's customization. I apologize. So let's point out how we got there to begin with. I always hit the drop down on the search command to filter to commands. All right. And I'll show you another trick. Everyone has talked about on these streams so far the S key for your shortcut toolbar. I'm going to go ahead and click the space bar because that's even easier to find for me. And if you hit the S key, and in my case the space bar because I customized the interface a little bit, it automatically activates that search. So bring up the search or the shortcut bar, then start typing equation. And here it is, and you can drag and drop this right onto your interface so that it's available at any given time. Really convenient. So I'm going to pop that open. And what we're doing is we're not creating much of an equation. We're just saying h equals 36. So this is actually what's called a global variable. The width, I'll call that W, we'll make that 72. And then I told you about the rise and the run. Now, in your local city or state, there are standards that define what it can be. So the run is typically, here in my location, which is Cleveland, Ohio, 10 inches. And the rise is actually defined by the max rise, the maximum it can be. Because if you get too big, it just gets too hard to climb up that step. And unless you're 6'4" like me, you might struggle. So let's make this 7.75, which is the maximum rise in my municipality, all right? So now we've defined some variables and those input values, and I'm just going to hit OK. If I come back to the sketch, then what I could do is, let's edit this sketch. I can right-click this dimension that I just added and select Link Values. All right. What this does is it gives me a drop-down list, and there are all the variables that I just created. We've got the width, and I could set that. I could add a dimension for the height, and let's just exit out of that and right-click. And once again, link the value to the height. So really simple so far. Let me tell you something, because you might be wondering, like, what are linked dimensions? A lot of people overlook this functionality, and they're definitely different than equations. And here's how. First, I'm going to draw a few lines. By the way, does anyone know how I'm drawing just a single line at a time? The trick is click, drag, and release. Click, drag, and release. And you could draw an independent line. Typically what happens is you click, 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 and it draws a bunch of chained entities. You could still do another keyboard shortcut, or I guess a mouse click shortcut. If I don't want to draw this final line, this chained entity, just double click. And then you could start a new chained line of entities and then double click again. So there's a few tips. I am really dirtying up my working environment, so let me delete all that. And then let's add some dimensions here. Has this ever happened to you? This is so annoying. When you're trying to add this angular dimension, but you want to put the dimension up here, it switches to the horizontal or vertical length. Anyone know the trick? Always pay attention to your little mouse icon right next to the mouse pointer. It's telling me that if I right click, it will lock that orientation. So let me right click, and now I can place this dimension text wherever I want with a left click. So again, that is a left click, then a right click, and then place a dimension, and left click again. Sweet. Oh, look at that. We've got Christian Harry from Avon, Ohio at Large Diameter Bearing Design. That's cool. Large diameter bearing design. I would like to see large diameter bearing machining as well. That would be neat. And oh man, so many people from India. Welcome all of my Indian friends. Hope you're all doing well. Okay. Let's do this one more time. And now, check this out. I can click this dimension and control click this dimension, and we'll right click and we'll link those to the same thing, the height, let's say. Immediately those both change to 36. This is again kind of cluttered right here. Let's move this out a little bit. And then this one, I'm going to do something else. I'm going to double click that dimension, double click fast enough so the modify dialog comes up. And to create an equation, you can create an equation on the fly just by hitting the equal sign. And then, watch this, I don't even have to type in anything. I can hover over global variables. There is my height, and I could select it and hit OK. So now we'll notice a slight difference between these. Number one, graphically, the equation has a little summation symbol, whatever that thing's called. I should know, I'm an engineer. And then the linked value, I should say, has a little chain link symbol. All right. So they're different. Linked values, though you can create a one-to-one equation where this equals that, linked values are a little more versatile in the fact that I can click on any linked value and let's say change that to 40, and they all update, even though I created this linked value over here first. I could double click on this one and change it back to 36, and it updates everything as well. Oh, I just hit exit out of the sketch. Now this one, if I want to change it, the equation, I can't. It's equal to H. So I have to go back to H either through the equation dialog box or double clicking on this original dimension that defined it, and then it will update. So there's a parent-child relationship with equations. And if it's just a one-to-one scenario where this equals that, that's why I prefer using linked values rather than equations. I save equations for when I actually need to do math. This divided by that, and we'll get there in just a little bit. Okay, so that is the first sketch. We are 18 minutes in. We'll make some progress. Don't worry. We'll catch up. Let's start a sketch on the right plane now, and we're going to create another layout sketch. And this time what I want to do is get an understanding of what the angle or the pitch of these stairs are going to be. So how do I end this chain of entities? Just double click, and then I will draw another vertical line right there. Don't have to escape and exit out of the line tool a bunch of times. And here all I'm going to do is, I don't care about this overall width. I don't care about the angle of this. The way I'm going to define this is by adding a dimension right here for the run. And we don't worry about that value yet because we're going to link it. And this dimension right here for the rise, right? And I'm going to right click and link this to the run. Remember, we input that as 10, so it jumps right to the 10-inch value. And I'm going to right click and link this. Let me show you this too. Something I always like to do whenever I'm getting into creating equations or linked values, on the drop-down menu, that kind of creepy looking eyeball in our interface, there is a D1 option. So that shows the dimension names. So go ahead and activate that. And by the way, you can be following along. I think that the pace of this, even though I haven't made a lot of progress yet, is going to pick up towards the end. So don't worry, all this is going to be available for direct playback on demand afterwards, and you can play it, pause it, and follow along at your own pace if you need to. Okay, so I'm going to link this to the rise, the maximum rise, not the final rise. And we'll get there in just a second. Look at that. The angle updates immediately. This represents the steepest angle the stairs can be. The next question is, how many steps are there really going to be? So we could figure that out. That's just some simple math, right? And by the way, look at that. The dimension names, with the reason I turned them on, automatically shows the name of the global variable. So that's pretty convenient too. When there's a linked value, the name of that linked value is displayed if you're displaying dimension names. Okay, so let's come back to the equation editor. We're going to try to figure out what the stair quantity needs to be, if I could properly spell. This is going to be, what is it? The height, and we can just click as we're filling out this equation, and it will automatically put in the proper nomenclature there. The height divided by the max rise. And that tells me that the stair quantity is going to be 4.64. We can't have 4.64 steps. This is exactly why we're designing our own stringers rather than buying the ones from a big box store. We don't want that little awkward 64% of a step at the end of our stairs. So let's see here. I'm going to change this to quantity, actually. And what I could do is, if you're familiar with Excel, we can use a lot of Excel type formulas. So I could type in int parenthesis and put a parenthesis on the back end of that, and that will change it, round it down to the closest integer value, which is 4. Okay, so it's telling me I need 4 steps. All right, so 4 steps. Let's see what the rise is going to be with 4 steps, the actual rise. So let's see here. We're going to say the rise is going to be the height divided by the stair quantity. Enter. 9 inches. That's not right, because 9 inches is greater than our maximum rise, which is 7.75. All right, let's fix this. I'm going to delete the rise. We'll save calculating that later. And I'm going to rename this one to stair quantity X. It's an intermediate stair quantity. In some cases it could be, depending on the overall height. We might divvy it up just perfectly where the maximum rise happens to be the exact stair height that we need for even spacing of stairs the entire way. But I can instead go stair quantity here, the actual stair quantity, and this is where we're going to get a little smart. And again, if you're familiar with Excel, this will make sense. I'm going to do an if statement. If the height divided by the max rise, or no, I'm sorry, the stair quantity, what I just did, is greater than the maximum rise, which is what we found. You could also type this out, max space rise, and you just got to put global variables within quotation marks. So that's what we just did. We know the result of this. Height minus or divided by stair quantity X is 9, greater than the max rise. So what do we want to do? Then do this. Do the stair quantity is going to equal stair quantity X plus 1. We need one more step in there to make sure we're less than the maximum rise. Otherwise, if it turns out that it's not greater than the maximum rise, then just use stair quantity X as is. So now we got some logic going on here where it says, all right, it does the math. It finds out that 4 is not enough steps. It adds one more, and it tells us that the final stair quantity should be 5, which means our rise should be the height divided by, once again, the actual stair quantity, the corrected stair quantity, which is 7.2. And 7.2 is, of course, less than 7.75, so we are good to go. So look at that. Equations. Pretty awesome. Now, it's not just cool for, we could have done this all in a calculator, but the great thing about this is as the overall height changes, all those equations will update, all my global variables will update, and those are going to be the things that drive these sketches. So let's draw this out again. This is a scenario for the max rise. We want to draw a scenario for the actual rise. So let me jump this out over here. Let's draw another, I didn't use my tip. I exited out of the line tool prematurely. Let's add a dimension. That's going to be the actual rise, and then the run is going to be exactly the same. That's a static value. All right, so let's right-click on this one and link it to not the max rise, but the actual rise that we just calculated for. And then, this is getting a little cluttered, but we could right-click on this one and link it to the run. Voila. So now we have the actual slope of the stairs calculated right there. All right, I dig this. All right, catching up on comments. Just print it out, multiply. Oh, okay, all right. Talking about printing formats, I'm not there yet. We'll create a drawing later, and we'll get there. Now, I've got a couple of sketches right here, and this is going to help me build the model that I need to build. Brian Zayas covered this in his video. It's good good practice to name these things. So let's call this front layout, and let's call this one side layout. And then I also like doing this. Layout sketches are a great reference for every downstream feature, and they should be easy to get to. So go ahead and add it to your favorites, which plops them right at the top of your feature tree so you can access them at a quick glance and not have to go digging for them. All right, now let's create the stringer. That's the fun part. I'm going to start another sketch, and let's think about this for a little bit. So what have we just sketched? Right here is the very front cut of the stringer. And then it's going to come across and up and across and up and so on. But is this right? This represents the ground. And we're going to have to put a tread plate on top of that stringer. And then a tread plate on top of here. So this distance right here is our, I drew that weird, is our rise. That's perfect. But our rise being the full distance right here doesn't make sense because we're not going to install a tread plate on the ground, right? So we actually need to compensate for that very first step, bring it down the thickness of the tread plate. So when I'm drawing this stringer, what I'm going to do is start with a construction line and draw it downwards, and then give that a dimension. Now this, remember, I said maybe even some of the SolidWorks co-workers that are on this stream might not know some of these tricks. This one I figured out on accident once, and it is cool. It comes in handy in all kinds of scenarios. What I'm going to do here is just type in 1.5, because that is the thickness of the lumber that we'll be using for the tread plate. And then I'm going to right-click. First, you got to exit out of the dimension tool. And then right-click, and you'll see linked values. You could create linked values on the fly. And if we do it in this instance, I'm going to type in thickness. And you got to spell it correctly, and you got to use the word thickness. You can hit OK, and it creates a linked value. Now, more on this later. but keep in mind that you need to type in thickness and you need to create it on the fly. And by the way, thank you, SolidWorks. You just reminded me that I haven't saved yet. So let's go ahead and save this on my desktop and call it stairs. Always hit Control S frequently, right? Okay, so now what we could do is we could start to sketch the side of the stringer. And you might be thinking too, wait a minute, I said my favorite modeling mode, there are a few people said, is weldments. Why don't you just draw a line or use that line to create and insert a 2x12 lumber member across that and then trim it up? I could, but while I'm in this sketch, it's also just as easy in this case because there's going to be so many cuts to it to sketch out what the side profile is going to look like. There's nothing wrong with this, right? Well, we'll find out later. So in that case, I started, again, 1.5 inches lower at the beginning. And then to fully define this, I'm going to need to select these entities and make them parallel. And anytime we're stuck with blue geometry, and I'm not sure what dimension I need to add, I just grab that blue geometry and drag it to kind of play detective and find out where it has degrees of freedom, the thickness or the width or the depth, whatever you want to call it. I need to tell this piece of lumber that it is going to be a 2x12, so that is going to be 11.25. All right, people are still telling me my volume's low, so I'm going to crank it up a little bit. All right, there is my fully defined sketch. Now I can link this. If I was going to create a bunch more side profiles of 2x12s, I would probably want to link that to 2x12 thickness, a variable like that, and then I could just link. But not necessary here. Now here is, oops, I forgot something, didn't I? I want to start at one end of the stairs and bring it over to the other side. So I need to put this on a separate plane. I'm going to roll back before I ever created that sketch because the plane needs to exist first. And then I'm going to select the right plane. This is a good keyboard shortcut by default. Hold down the Control key, and I selected the right plane so it becomes visible. And then drag while holding the Control key, and you'll actually prompt the plane property manager to come up. Now, if I select that point at the end of my sketch that define the width of the stairs, it snaps coincident to it, and I could hit OK. And no matter how that width changes, the plane will move, which means when I roll back down here and I select this sketch and edit the sketch plane, I can make it jump onto that one and hit OK. By the way, how do I click OK so quickly if you've seen me do this in the past? I just hold down my right mouse button and swipe right. Now, that's called a mouse gesture. And let's talk about that for a second. But really quick, I'll hide this plane. And you can see how the sketch just jumped right out onto that plane. Perfect. So let's customize our interface a little bit. And let's jump over to the mouse gestures command. And a few people have brought this up in previous streams. In fact, I saw Michael Steves on the previous episode use his mouse gestures, and he had 8 slices. And I think Brian Zayas does the same thing. Those guys have way sharper brains than I do. And if you haven't adopted mouse gestures yet, I recommend starting off with less slices. Because if you, in their mode, if you drag your mouse up at an angle versus just perfectly right or perfectly up, then you'll be activating a different tool. And you can see you could set different tools for each mode. I'm envious of the people who can memorize all that. I keep it simple. 4 slices. I swipe to the right for OK, swipe to the left for cancel. If you haven't adopted mouse gestures, set that up as a minimum because there are no 2 more common tools than that. All right, now let's go ahead and extrude this. Watch this. I'm going to select that sketch, hit extrude, and how far do I need to extrude it? Well, check this out. I've got a new addition to my extrude property manager, link to thickness. So remember when I created that 1.5 inch thickness and I created that linked value, that prompts every extrusion and extrude cut feature to include this link to thickness. This is something exclusive to our sheet metal modeling environment, but is totally handy when you're doing construction or cabinetry, where you have a common thickness of material. Like if you're creating a cabinet, you could create a box, extrude, link to thickness. Create a box, extrude, link to thickness. And if you ever decide to change from like 1/2 inch material to 3/4, one global variable to switch, and it updates all those boards, all those features at once. And you didn't even have to create the linked value. All you had to do was click a little check mark. That is a Jordan Todich original, found it by accident, and it's super useful. I use it all the time. So now all we have to do is flip the direction, and we're good. Now you might also be asking, why didn't you do some one of the cutouts or all the cutouts for those little notches of the stairs on this stringer right away? Well, that would have required me to do it inside the sketch. I feel more comfortable controlling patterns of features rather than patterns of sketches. Michael Steves showed that in his stream, creating a sketch pattern, which is really cool, but I'm just a little more comfortable doing it with features. No biggie. To each his own. All right, so let's create that notch. This is a super simple sketch. Just draw a horizontal edge, a vertical edge, and then close it off. It's just a little triangle. We only need one dimension here. We could either insert the rise or the run because the angle is already defined, and that's always going to be a right angle with horizontal and vertical edges. So now I can just right click and link the value to the this time the run. That is a perfectly sized notch right at the beginning of our stringer. I'm going to extrude cut that. I have a keyboard shortcut for it. I highly recommend keyboard shortcuts. It's just easy. So I do E for the extrude key. I do Alt E for extrude cut. R for revolve, Alt R for revolve cut, if you want to take my advice. And look at this too. Automatically, link to thickness is selected. So you could get really fast creating features. You don't even have to input a dimension. It's automatically checked, even for the extrude cuts, and you're done. All right. Now, let's go ahead and pattern this. So I'm going to fire up the linear pattern command. And okay, I'm a SolidWorks employee, but I think it's fair for me to criticize the layout of our interface every so often. It always frustrates me because as soon as I pick a direction and start entering the parameters of the spacing of the pattern, I expect to see a preview. So if I come down here, I scroll down and select the features first. And I highly recommend that, because then that way, when you're filling out this information at the top of the property manager, I wish the features were at the top. That would fix everything. But when you are filling this out, you see a preview right away. So let's just put in some random number here, like 20 inches, and let's just do 2 for now, which for linear patterns, you always do the total quantity, including the seed feature. Okay, so I did the right direction. I referenced our layout sketch, and that's pretty important too. I could have referenced this edge, right, for my direction of my linear pattern, but if I can, I always take it back to the layout sketch, because the layout sketch is always going to be there. I might fillet this edge. I might reverse the extrude direction, and that edge might jump to another edge or something like that. So whenever possible, that's another benefit of creating layout sketches. Make all your references back to that, because you know that's never going to change. If I delete that line in my layout sketch, then shame on me, right? So let's go ahead here. This linear pattern feature, if I select it, the dimensions associated to it, the parameters associated to it, pop up on the screen. So I see that it's a distance of 20, and it is a quantity of 2. what do I need that distance to be? Well, if we look at the layout sketch, I actually have that distance right here. But I need a dimension. So I'm going to exit out of this. I'm going to double click on that layout sketch to activate it. And it's getting a little cluttered, but I'm going to add one more dimension from this point to that point. Make sure to right click to lock that orientation. I'll space it way out there. Now, notice that the dimension's gray. This was already a fully defined sketch, so that will automatically be added as a driven dimension, which is just basically a measurement. So now I could come back here, select the linear pattern from the feature tree so that I can see this dimension, double click it, and sure, I could have created a linked value and just right click link value. I'm just going to do this because this is a one-time use case scenario. I'm going to hit the equal sign, and then I'm going to come back to my feature tree, select the side layout sketch. That temporarily shows all those dimensions. And after I hit the equal sign, I can click this dimension, and it says that this pattern distance is going to be equal to whatever that dimension is, whatever that measurement is. And that's going to change as my overall height changes and as my, everything else changes. My new rise is recalculated. And that's D1 at sketch layout. So I can name it so we don't have that D1, but that's a naming, or the standard naming convention. All right, now if I hit Control Q to rebuild, look at that. All right, perfect distance. What about the quantity? Well, let's select that again. Here's the quantity value. Right click on that and link that to the stair quantity, right? We already have that defined as a global variable. So now if I hit Control Q one more time, voila, this looks perfect. Let's check it out. Let's do a little inspection. If I come to the side view, we are going to see here that if I fire up the measure tool, that this edge is 7.2, just like we expected, right? That's our rise. And certainly this edge, let's unselect that. This edge will be 7.2. What about this distance right here, from this to the ground? 5.7. Well, remember, we're going to have a tread plate up on top of that, which is 1.5 inches thick. So 5.7 plus 1.5 is 7.2. Perfect. And then let's clear these selections. Come up to the top. Now, when we define this point right here, we were defining the top of your deck. So you're usually going to have like some floorboards up there or some decking. That is the top of that. So that's what they're stepping onto. And then you have this right here. So that's 8.7. But don't forget about our tread plate, 1.5 inches. So 8.7 minus 1.5 is 7.2. Everything is going to be exactly 7.2 inches for the step. And remember, our big box store, I guarantee this is not 7.2 inches for each one of those steps. So this is looking perfect. The question though is, have we mastered the model? What happens if I click on the front layout sketch and change this height, let's say to 80, and hit a Control Q? Oh, yes. If I click this edge, a live measurement is right down here, and now it's 7.273. All right, it's going to be different for every height that we add, and I could go on and on and on. But let's keep it moving. The front layout now, let's take this back down to 36 so it fits on the screen better. That is pretty cool, right? Okay, let me catch up with comments. Andy Barnes says, I've only ever used it in relation to sheet metal. Pretty cool use case, thank you. All right, link to thickness. People are liking the link to thickness. That is one that I stumbled on. I can't take full credit for it because it was an accident, but at least I figured out how it could be used. All right, so now what we need to do is we need to consider the width of this staircase. You might think, oh boy, here we go again, a bunch of equations and all that. No, I'm just going to fire up the linear pattern command. The direction is going to be this, and the features that I'm going to pattern are going to be the extrude cut, the pattern. Too much selection for me. I prefer selecting bodies in this scenario. And when I just want to pattern an entire chunk of material, it's a lot easier to go ahead and select the body. Now I could say I know that the distance between each one of these stringers per code needs to be 16 inches, just like studs on a wall. They need to be 16 inches center to center. So then I could just kind of eyeball this, like, that looks about right. And then I can mirror that first one over to the other side, and we'd be good. But what happens when the width changes? Okay, equations, right? No, we don't need equations here. What I'm going to do is show you a new feature, relatively new feature, called up to reference. This is super nice. It takes all the headache out of creating those equations like we did for the quantity of stairs and all that, and wraps it up into the linear pattern property manager. So here's what we do. We say what the reference is that we want to go up to. I started at this end of the line because of the plane, the sketch plane, and where that body existed. And I'm going to select this point as my endpoint. Check this out. If I change this to 20, then SolidWorks will automatically calculate that only a total of 4 instances can fit in here. If I change it to 25, only 3 could fit. And if I change it back to the 16 that we need, it automatically figures out that we need 16. By the way, you can also specify the quantity and have SolidWorks, the linear pattern tool, calculate the spacing. So you go either way depending on what's more important for you. So I'm going to go ahead and hit OK. And I'll also fire up the mirror command because I want to mirror across the right plane this very first, once again, body, not features, but this entire chunk of material over to that side. We're looking good. You might think like, well, why don't you evenly space those out? You don't have to in this scenario. And actually, most people prefer not to because once you cover this up with the tread plates and the kick plates, you won't be able to see those. And now you'll know every 16 inches you can screw or nail down. So that's totally fine having that smaller gap right there. Okay, let's test this out really quick. Here's a fun way to test. Let's just select that front sketch layout. Notice I have Instant 3D on. This is something I turned on in like 2008 or 2009 and haven't turned it off since. That activates these little blue dots at the end of every dimension, and I can drag it, and watch how smart this is. As I drag, it will just add a new stringer as necessary, live on screen. And by the way, you can snap to these dimensions right on the ruler and come back right to where you might have been. Now, something to be aware of, I found out, I didn't realize this at first, but, oops, sorry, just kicked the camera. If you use Instant 3D, that actually overrides the link value. So notice that that's back to D1. So I could right-click this and link that value once again back to the width. So just be careful about that behavior right there. All right, we've got 10 minutes till the end of this hour. I'll probably go like about 5 minutes over if that's okay with everyone. And then I'll open it up for questions too, if you'd like. Let me catch up on here. Oh, Charn, what's up, man? You just joined. You missed quite a bit. But after this session's over, go back and watch it from the beginning. It'll be live on demand. Good to see you, Charn. Jesse Hawk, what's up? It's been a long time since we've talked. Another Ohio guy. All right. This is great. I'm looking forward to catching up with you all with questions at the end. Feel free to ask questions now, but better save it to the end so I don't accidentally miss it. All right, now we need to actually use weldments. Remember, I ignored it for this first piece. That was just an extrusion. and we'll get to that in a little bit. I'm going to start a sketch on this top tread, and we're going to draw a line. Now, let's get a little fancy here. I'm going to draw a line past the extent of that edge so that the tread plate, it overhangs a little bit off the edge. And by how much? Well, that's up to you. Let's make this horizontal, would it be? And let's add a point to this, and then snap that point to that corner. So now we're fixed right there. Over here, I'm going to do the same, add a little point, and snap it to that. And now within this sketch, I could just add a dimension from that point to that point, and we can make this dimension. I'll put this off in the white area so we can see. Let's just make that equal to maybe the thickness. So check that out. While you're filling out an equation, you can reference all your variables. This is going to be linked to the thickness, which is down here. Let's say divide by 2. So that will end up calculating to 3/4 of an inch thickness. But, you know, if you're in a country where 1.5 inches isn't the standard width of the board, you can download my model and change just the thickness value, and you'll be able to update everything all at once, just with one value, and including this overhang. So if you change this to 1 inch or something like that, it will change to a 1/2 inch overhang. So let's do that again. This equals the thickness divided by 2. So you can type math right into the modified dialog box as you go. The key is you just have to add that equal sign at the beginning. I'm going to draw one more line, and this is following up from where Mike Sandy left off with weldments. All you need to do to create a weldment, thanks again for reminding me, SolidWorks, to save. That's a good idea. To create a weldment, all you need is a line. So you don't have to create the complicated sketch that I started off with. And I could come over to the Weldments tab, and the people that mentioned weldments are their favorite modeling mode already know this. I'm just going to fire up a structural member. And remember, that link that we'll make sure to post here, this lumber profile, and Mike Sandy actually covered this, how to create it, by creating a design table to automatically generate all these. That's exactly how I did this as soon as that functionality was available. And now what I get is a list of either softwood or hardwood. And by the way, there's a bunch of standard types of profiles, structural steel and things like that you could download. And now I could set this to 2x12. All I have to do here to insert it is click that line that I sketched. It will overhang on either side by half the thickness. And then I can locate the profile down here at the bottom of the property manager to that lower corner point. That's perfect. It places it right in position. And let's hit OK. If I come to that side view to see what just happened, that looks great. And of course, the distance from here to here is going to be 7.2 inches. Now, I need to put a kick plate on here as well. We're going to use a 1x6 for that. So that's why we chose 10 for the run, because 11 1/4 for the tread, that leaves 1 1/4 overhang. With the 1 inch thick lumber, which is actually 3/4 of an inch, we'll still have a 1/2 inch overhang over here or so. So that's perfect. Let's create another structural member and set it to a 1x6. Pick this edge. Let's once again link that to, or locate the profile to this corner. And then all we got to do is rotate that by 90 degrees. This always happens to me. Does this happen to anyone else, or is it just me? Whenever I want to rotate, I always rotate in the opposite direction. All right, so this is actually 270 to go in the reverse direction. And there we go. Let's hide this sketch. And now, what do we need to do? We need to create another pattern. All right, simple enough. And then we are close to finished. We just need to create a drawing of this. I'm going to show you a little bit about cut lists, which are awesome. All right, so linear pattern. Let's come back to the features tab. Remember, I like to select features or bodies in this case, because we're patterning the entire chunk of material, not just specific features of it. And for the direction, we're going to reference our layout sketch again. Again, I could select this edge, but the layout sketch will always be there. Why not just use that reference? And we're not doing up to reference this time. We're going by a specific spacing because we know that spacing from the reference sketch. So let me flip that direction, and we'll just leave it at what it is right now because we're going to right-click on this and link or add an equation. All right, so if I select on the linear pattern, it shows me all the dimensions. They're kind of hidden over here. There's the quantity. There's the spacing. I'm going to double-click on the spacing and make that equal to what? I need to show the side sketch again and make it equal to that dimension. There we go. So second time we've been able to use that. Not a bad idea. And then for the quantity, if I select that linear pattern again, I could right-click that and link that to nothing else than the stair quantity. And hit Control Q, and everything updates. Almost perfectly. What did we do wrong? The quantity of steps is 5 because you need to step up onto the deck, but we don't need an actual tread plate there, right? Because that part is already built, or your porch, or whatever it may be, or your floor. So let's modify this. That dimension doesn't need to be a linked value, so let's right-click and unlink that value. Or double-click. Oh wait, no, that's a dimension. I'm sorry. There we go. Right-click and unlink this value. And then double-click it. We're going to add an equation. It's always going to be equal to the quantity of stairs, stair quantity, minus 1. Control Q. Updates perfectly. All right. So there we have it. And again, let's test this out. Let's select that front sketch and change this height to, you name it, 120. Control Q. Ha ha ha. Isn't that cool? So now whenever you need to build a set of stairs, don't buy that cheap, well actually expensive pre-cut stringers from the big box store. Just jump into this model and calculate exactly what these dimensions need to be. Now let's make those dimensions in the drawing. All right, I'm going to jump back, and just to make everything fit nice and easily on a sheet of paper, let's bump this down back to 36 inches. And then let's make a drawing of this. So I'm going to save this really quick. We're about done. 2 minutes left. I can maybe make a drawing in 2 minutes, but not with all that I want to explain. So like I said, we'll probably go just a little bit over. All right. Gonna hit OK. And listen, this is a cut list that we're going to be using to define most of these dimensions. So I'm just going to bring in the isometric view. And in fact, we probably don't need to show these sketches anymore either. So let's hide those. And then let us create what's called a weldment cut list. Now in an assembly, you have a bill of material. Bill of material is based on components inside of the assembly. A weldment cut list is based on the bodies inside of a part file. So if you haven't noticed, we've been creating a bunch of separate bodies inside of this part file. So let's go on here. This is going to be, let's create that cut list. The cut list I'm going to use is, forget it, we'll just use the standard one. I'll show you how to customize it really quick if we want. First off, they always kind of come in big. grab the lower right-hand corner and just drag, and you can resize a bill of material or a cutlass that way. And I could drag this down to dock it down there. And look at how convenient this is. It tells me that there are 4 1x6s cut to 72 inches, 4 2x12s, those are the tread plates, cut to 73, and then 6 of what? Blank. Why is that? I'll tell you why. It's because this is nothing more than an extrusion. And if we take a look at our cut list in here, by the way, this is automatically working because I've selected from the right-click menu, Update Automatically, and I save that into my part template so it always behaves that way. And Andy wants a swing set. That's another one. I did build my kids' playhouse, which was all designed in SolidWorks, of course. Maybe that could be a session. That has an attached swing set. All right, now if I right-click and hit Properties here, look at what weldments are doing in the background. It's automatically calculating all kinds of really useful information. The length is automatically calculated. Let me just expand this out to 72 inches. The angle, if you had a miter cut at any one of your members, it would tell you what that angle is. So you really don't need drawings. You just need this cut list, and you could get going. But if I click on that original extrusion, the stringer, which, by the way, is highlighted down here as you're clicking on the different objects, or cut list items, I should say, has nothing. It's nothing more than an extrusion. But watch this. This is a really cool feature that was added a handful of years ago, and it's so powerful. You could use this in all kinds of scenarios, but in this case, it's really convenient too. I'm going to select Create Bounding Box. Now, what actually happens in the background is if we expand this cut list folder, there's a 3D sketch that is automatically generated to wrap around the smallest box that could possibly fit around that geometry. This is essentially the raw stock 2x12, cut to the exact length that I need it cut to. So what SolidWorks does is, look at that, it already renamed it to plate, 1.5 by 11.25 by 48.413. That's the length that we need. So let's right-click and hit Properties and see how this is working. Perfect. So it's automatically calculating the thickness, the width, and making separate properties for each one of those. If I come back to my cut list now, all right, we're halfway there, kind of. I still need the length value. So let's jump back over here. I'll show you a little trick. We can right-click on this and hit Properties. And notice that the structural members have a property added to them called length. So all we need to do is jump back to this guy and create a property called length. And what is the length? It's going to be equal to whatever this length is. So if we uncheck this little automatic calculation thing there and hit Control A to select all that coding or that syntax that automatically calculates the length, I could just paste it right into that property. So now there's a length property that the table can reference. And if I don't like this name, this automated name that it gives it, and I want to stay consistent with the rest, I could say 2x12 lumber to stay consistent with the rest. And if I jump back over there, Control Tab to switch windows, look at that, 2x12 lumber, 48.413. Perfect. And that's always going to update no matter what I change this dimension to. The final thing we need to keep track of is how the heck are we going to cut that stringer? We need dimensions for it. And that is just one body in an entire part file. So how do I show that in a drawing? So easy. All I need to do is bring up my shortcut bar, and on the View Layout dropdown, we have something called the Relative View. Now I could select this model and it will jump over to the model and ask me, what do I want a relative view of? I could show the entire model, the entire part, from a unique angle and just specify this is going to be the front in this view and that's going to be the side. That's okay. Or I can say, I just want to show one specific body by clicking Selected Bodies, and this is going to be the front, And to take advantage of our drawing layout, I could say that this is going to be the bottom. Now it brings me right back to the drawing. I can plop that in there, and then we can quickly change the scale, maybe like 1 to 8 or something like that. Take advantage of all this space. And now add some dimensions. Little trick, if you double click within the boundary of a view, then it locks your focus to that view, and then you can use the line tool to sketch the geometry. So what I'm doing is I'm just sketching a vertical and horizontal line. Sketching inside of a drawing is a little different. All the controls for like relationships are popped over into the side panel, the property manager. And I could window select both of those and set it to for construction in the property manager as well. And now I can create some ordinate dimensions. So let's go ahead and do that. Ordinate dimensions are just nice and clean. And I can pick on that corner point, that corner point. There's another way to do this in the trade that besides, dimensioning every single tick point of where these stairs need to be, but you need a special tool to be able to mark these steps off consistently. Here, all you need is a measuring tape. So that's pretty neat because we have the power of SolidWorks. And then I could add one more ordinate dimension over here on the side. I told you guys I like to talk. No one is surprised right now. None of my coworkers are surprised, or the people that know me from Ohio, that I went a few minutes over. But I think it's worth it because we need to finish this story. Here is your layout for marking this off perfectly to the third decimal place if you wanted to take it that far, and if you had a measuring tape that would go to that level of accuracy. Perfect. I think we are done here. The only thing left to do is answer some questions. Oh, Mark Schneider. Of course you use 8 slices in your mouse gesture. Mark Schneider he just went with the Model Mania overview. Amazing. This guy is a wizard, a legend of our time, someone I looked up to for years. And much love to you, Mark Schneider. And of course, I would expect you to actually be using 12 slices. All right. We are doing very well here. We're wrapped up. Let's open it up to questions. Go ahead and ask questions. If you want to see me back, maybe do some surfacing, write that in the comments. But most importantly, hit the subscribe button, hit the like button, so that we can make sure that I get permission to come back. Maybe I won't because I went over on time. So let us hear it. And the one other thing that I figured I'd do while you're asking some questions is, let's see here. Let's take a look at an actual piece of 2x12, right? So this is a scrap piece I had left over from a project. And the typical way that people do this is they'll get these little attachments to a square like this that screw on, and they lock in at the perfect dimension. So you can just find your dimension right there, lock in on it, and move this down, move it to the edge, and trace that, and that's a super easy way to do it. But if we have all of our dimensions, one thing I like to do is get yourself a speed square. This is a speed square. And if you get a good one, don't get any speed square. Get one that has these little notches right here. So that one dimension that we had, the depth of the deepest groove, the deepest notch, 5.84, we can mark that off over here. And just set our marker right in that notch, that groove. Start at the end and slide all the way up. I'm running out of space right here. But you'll have a line there. Then you could take your measuring tape right along there, mark off each one of those points, and then come back with this, mark off the points for the tips as well, And then it's just a matter of connecting the dots. Boom, 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 and you're done. All right, let's see what questions I got. 8 slices. More people are using 8 slices. I can't believe it. I feel inadequate based on how many people use 8 slices to their mouse gestures. Nuno, I love that feedback. Thank you very much. It's been a joy. Let's see here. Oogly Boogie or Boogie or Boogie. I don't know. That's a great name. I love it. Thanks for the feedback. When are you going to 3D model my house for me? If the price is right, we might be able to work something out on the side. Just don't tell SolidWorks that. No, I'm kidding. I'll definitely give you some tutorials. Jerry Castle, you're in. Thank you very much for logging in. The Neo Swug, our Northeast Ohio user group leader, along with Craig Rydell. Awesome. Thank you, everyone. I am going to be done. And yes, Mark Martell, I will design and build your stairs for you the next time we can travel to Boston again. I'm signing off. Thank you so much, everyone. Share this, like it, subscribe. Appreciate it. Take care.